Hello, welcome back to our discussions of MySQL. Today we're going to look at something very important to the select statement, and that is the use of the aggregate functions. Really integral. There's some functions in SQL that are kind of extra functions that provide some useful utility to you, but the aggregate functions are really integrated into the select statement in a way that we'll reveal in a couple of lectures from now. So let's take a look at them. So I have my select statement here. First of all, let me close all my tabs. So I'll close other tabs and then close this one. I also want to clear my result tab, so we'll just run these straight out. I have several functions here that have to talk about the aggregate functions. That is several statements in this script file here. So the first thing I do is select star from classic model payments. So this is our business here, Classic Models. We're a wholesale business that sells to retail customers. That's why the payment amounts are relatively high, I think. So we see customer number, and not surprisingly, this customer has paid us 3 times. We've given us 3 payments. These are the check numbers we have here, again showing every column and every row from the payments table just to get an idea of what's there. Relatively simple, payment date and then amount. So let's take a look at the aggregate functions. So there's many aggregate functions. We'll look at a valuable 5. The average, the count, the sum, the max, and the min. So we have aggregate function name, one of these, and then the distinct keyword or the all keyword. The all is the default case, and that's what we'll look at first. That is all of the expression rather than a unique expression. So we'll look at that a little bit later. So select the average of the amounts. That is all of the amounts that you have. What distinct would do here in the context of the amount, and I have to express it right. This is the default all. Nothing wrong with saying the default, but you don't need to, and it's not normally done. But if I wanted a distinct amount, that is, let's say if I had 2 payment amounts that were the same value, then the second value would be eliminated from the average. And sometimes you want to do that. Not this time. We'll say the average amount as average, and that's our column alias, and that's our second query. So whenever you have an aggregate function used in this fashion, you'll always get one row result, because think about it. It's aggregating it up. It's counting it up and saying, this is the sum, or this is the average in this case. And here we have the average amount, and you can see that it has a little bit more digits than we would normally expect for a dollar amount. So in the next case, I'll round it up, average to the dollar. So we'll use the round function here on the average amount, and that'll round it to the dollar. And we see the results there. And if we added additional parameter to the round method, we'll take the average amount, comma 2, and this will round us to the penny. And that's the way we're normally used to seeing money, rounded to the penny. And there we have the average amount of payments that we have in our original table here, average amount here. So presumably if you took a calculator out and counted this up and did the proper averaging across the 273 payments that are found here, then you'd come up with the average that SQL has given us here. Okay. And then see, we're going to use count here. So this is customer numbers here. Customer numbers in the payments table. So select the count of the customer number in the payment table. So we count 273 rows. This is the count of the customer number. Now, what will happen here is that if customer number is ever null, then it wouldn't be counted. This is the count of non-null customer numbers. Now, customer number has to be there for the payment to be valid. So we'll never encounter that. So the number of rows is equal to the number of customer numbers that we count. So count does have, the count aggregate function has a special syntax, and that is it works with a star. So that's acknowledging that if you count an individual based on an individual column name, you may encounter nulls and not count it. So count star says count the rows in the payment table, and that will always be the total number of rows given the where clause that we don't have. So every row in this table, count it. Whereas this will only count customer number. They're going to be identical results here. Customer numbers in the payments table and the number of rows in the payments table are the same because customer numbers can't be null in the payments table. So count star for the number of rows. So we're going to switch over to rows in the customers table. and 122 rows in the customer table. So we'll maintain customers. This is our data table for customers that we have here. Let me go ahead and select rows so we can take a quick look at that. Customers. So our data table for customers maintains their addresses, their customer number. So, for example, this payment, if you notice the payment is relatively thin on information, but if you can combine that with the customer information, then you'll have the full payment scheme there. So we have customers, so this is how many rows that are in the customer table. And then we have count of state in the customers table. Now, since our customers can be international, sometimes the state is null. If you look over here, we can see that state is sometimes null. So that's to show you the distinction between counting a particular column versus counting the rows in the customer table. In this case, since state can be null, the count of states is 49. So we have several customers in countries that don't have states. Okay, this next example is our first example of the use of the keyword distinct here. So we have distinct customer numbers. So count the customer numbers in the payments table. So we saw that by looking at the payments table that we saw several customers have multiple payments naturally in the payments table. This says I want a distinct count of the customer numbers that have up here in the payments table. Suppose you want to know how many customers have made payments to us without duplicate counting of the results. And so a total of 273 total customer payments, but from 98 distinct customers. And I have a bug in this one, or a flaw in my syntax. Let me fix that, and I'll come back to you. Missing a comma. So we'll run this I'm just going to show this. I'll put the cursor here and run the iBar version of it, and we'll just see one query come up. Still here. So, fixing up my example, I have really an example that kind of rounds up all the aggregate functions. So average, all average, a distinct of the amount. Now, these two numbers are the same, and that tells us that in the payments table, all payments are different from one another. If all payments are different from one another, then distinct will be the same as just give me all of them. Now we have the sum here, $9 million. The maximum payment made, about $120,000. And the smallest payment that we find, the minimum payment, $615. So, very important topic, and we'll round on this. We'll come back to it because it turns out aggregate functions have a superpower when combined with some other clauses in the select statement, and we'll visit that probably in a couple lectures from now. See you then.